Hey there, here we go again with college algebra. We're in chapter 3 and 3.3 for that matter, dividing polynomials using the factor theorem. And so we're going to have to review long division and talk about how to do that. Synthetic division is kind of a shortcut version of long division, but it only works in certain cases. Those cases, however, happen to work for us today, so that's good. And then we're not going to talk about the remainder theorem, but we are going to use the factor theorem. And that's something you'll be expected to understand, that terminology. So make sure you know what factor theorem means so that when it says use the factor theorem, you'll know that means you got to divide. Okay, so let's talk about long division and remind you how to do that. So the textbook gives you this lengthy 6-step process. Okay, I'm not going to read them all out to you. I'm going to just show you. But if you want to copy these down, again, they're in your textbook, but also if you want to copy these down, you might want to pause the video here for a moment and write these down, 1 through 4, 5, and 6, if you like to use those kind of things. But I'm going to jump right into the first problem. So the process works as this. What you do is you take a look at the first term that you're dividing by and the first term you're dividing into. You have to write these in descending order. You have to write your polynomial in standard form, highest power to the left. All right, so you look at x and you look at 2x cubed. You ignore everybody else for right now. And you say, what do I need to multiply x by to get 2x cubed? Or another way to say that would be if you were dividing x into 2x cubed, what would you have left? All right, so obviously we'd have a 2, and then we'd need an x squared, right? X squared times x is x cubed, 2 times 1 is 2. And so if you took 2x squared and multiply it by x, you get 2x cubed. Okay? But this is not just an x, this is an x minus 3, and so you got to multiply the whole group by 2x squared, distribute. 2x squared times negative 3 is negative 6x squared. And then just like with long division of numbers, you now subtract this new thing, but you subtract the entire group. And what should happen is this power of x cubed should go away. 2x cubed minus 2x cubed, no x cubes. That's great. That's what I wanted. But then we have negative 3x squared minus negative 6x squared. Negative 3 plus 6 is plus 3x squared. And then we bring down the rest of the polynomial that's left. Okay, so this 0x cubed, it's not there anymore, right? We don't have to worry about it, 0. And so now we do the exact same thing looking at x compared to 3x squared. So x goes into 3x squared, we need a what? We need a positive 3, and we also need an x. X times x is x squared. So you take 3x times x, and that would give you 3x squared. And then if you distribute 3x times negative 3, you get negative 9x, and again, we're going to subtract the whole group. We did it correctly. This x squared becomes 0x squared, it cancels out. You get negative 11x minus negative 9. Negative 11 plus 9 is negative 2x plus 7, bring down the 7. And then what do I need to multiply x by to get negative 2x? I need a negative 2. And so negative 2 times x is negative 2x. Negative 2 times negative 3 is plus 6, but we're going to subtract the group. Negative 2 minus negative 2, negative 2 plus 2 is 0x, good. 7 minus 6 is 1. Okay? And so what that means is when you take 2x cubed minus 3x squared minus 11x plus 7, when you take that and you divide it by x minus 3, you get 2x squared plus 3x minus 2, but then you have a remainder of 1. Right? Well, this is algebra class, so we don't write it that way. How we write it is we write 2x squared plus 3x minus 2 plus the remainder divided by whatever we were originally dividing by, in this case x minus 3. So one way to look at it is there are kind of, this is the whole numbers, right? 2x squared plus 3x minus 2 is kind of the whole group that comes out of this when you're dividing by x minus 3, but then there's a little remainder left over, and so you put that remainder over your original divisor, x minus 3. Okay, and that's the way we write our final answer. We don't put R1 or whatever. Okay, this is the way that we write it. All right, so with that as a primer, why don't you guys try to divide this one? Pause the video at this point and divide 7 plus 9x minus 3x cubed by x plus 2. Notice there's no squared term here. You got to take that into account. And also make sure that you start off by writing this in standard form. Okay, so pause it, take a minute, solve it out, and we'll go over it together in a minute. Okay, so what do we get here? We get x plus 2 is going to go into negative 3x cubed plus 0x squared. I need a spot for x squared because I might get an x squared when I'm doing the division, plus 9x plus 7. So if you didn't do this 0x squared, if you didn't do that and maybe threw you off a little bit, you got stuck, then pause the video now and start over again. All right, so what do we need to multiply x to get negative 3x cubed? We need a negative 3, and we need an x squared to get the 3x's total. Take this and distribute. You get negative 3x cubed, but remember I got to distribute around the whole thing, and then I get a negative 6x squared. This is why it's important to have the 0x here squared, the 0x squared, so that you've got a column for this. We subtract, remember the whole group. Don't forget the group. Negative 3 plus 3 is 0. 0 minus negative 6. 0 plus 6 is 6x squared. And then I go ahead and bring down everybody else. Okay. I need a 6x next. 6x times x is 6x squared. Distribute, you get plus 12x. Subtract the whole group. 0x squared. 9 minus 12 is negative 3x plus 7. And then I need a negative 3 here in order to multiply through. So you get negative 3x minus 6, subtract the group, and we get 0 x's, and we get a positive 13. And so my final answer is negative 3x squared plus 6x minus 3 plus 13 over x plus 2. Okay? You got to have the plus or the minus there. Okay? Adding or subtracting, this is another term. It's the remainder term. So you get added or subtracted. Okay? All right, so now let's take a look at synthetic division, which is a shortcut version of long division, because all that really happens is we're looking at the numbers here. We're looking at the coefficients as long as we're in the right order. Okay, and so that's what we're going to do. But this only works for divisors that can be written as x minus c. So what that means is if you're dividing by x minus 2, then c is equal to 2. But if you're dividing by x plus 4, then c is what? It's minus 4. So you've got to use it that way, okay? And so, again, just like the other one, they give you a lengthy step-by-step process here. Write these down if you want. Pause the video and write them down, but I'm going to go through and walk you through how to do synthetic division. We're going to do synthetic division with x cubed minus 7x minus 6. And we're going to divide it by x plus 2, which means the c is minus 2. All right, and again, don't forget you've got to have that x squared term, right, taken care of, so there's a 0 there. So we want to think of it like this. And so synthetic division setup says we put the negative 2 out front, and then we put the 1 for the x cubed, 0x squared, negative 7 x's, and negative 6 the constant. Okay, so here's the process. You start with the first term and you just bring it down, period. You don't do anything. Now take negative 2 times 1 and move it right here, negative 2. And then we add these together. 0 minus 2 is negative 2. Take negative 2 times negative 2. Multiply those together. They go up here, positive 4. Add these together, you get negative 3. And then negative 2 times negative 3 is positive 6. Negative 6 plus 6 is 0. And this last bit is your remainder term. Remember that this started with x cubed, and this came from an x plus 2, so this guy is an x squared term. And this guy's an x term, and this guy's a constant term. And so the answer then, right, if you took x cubed minus 7x plus 6, sorry, that's a minus 6, right, and divided by x plus 2, you get what? You get x squared, 1x squared, minus 2x, minus 3 plus 0. There's no remainder at all. All right, and that's going to be really important. When we get no remainder, that means this x plus 2 went into that function evenly. Okay, and what that means is that x plus 2 has to be a factor of this, right? Because if you multiply both sides by x plus 2, what do you get? You get x plus 2 times the group x squared minus 2x minus 3. So you can see that when you divide, if you get a remainder of 0, then what that means is that this x plus 2 is a factor of this polynomial, and therefore that gets you started on factoring. And then I could factor this later because it's a quadratic, right? So this is a very powerful tool if you get a remainder of 0. You won't always get a remainder of 0, but we're going to talk about the factor theorem here in a minute, and that's what's going to lead to that. So you guys do a practice with synthetic division. All right, here's the function. It's 3x squared plus 5x minus 5. We want you to divide that by x minus 3. Okay, and so what's the setup look like? You guys are going to pause the video and try this on your own, but just to make sure you get the setup, there's a 3 here. Okay, and then there's a 3 and a 4 and a minus 5. And that's how we're going to start. Okay, so go back and look at the old example if you need to, but go ahead and try this one on your own, and then we'll go over it in a minute. Okay, so what do? We bring the 3 straight down. 3 times 3 is 9. We add 4 and 9, you get 13. 3 times 13 is 39. And so we get a remainder of negative 34. Okay, so if you divide 3x squared plus 4x minus 5 by x minus 3, you end up with 3x plus 13 minus what? 34 over x minus 3. Okay, that's all it is. Synthetic division is a much quicker way to do regular long division, but it only works for terms of the x plus c or the x minus c type of format. So I mentioned the factor theorem a minute ago. Here's what the factor theorem says. The factor theorem says if f of x is a polynomial, then if f of c equals 0, x minus c is a factor, and if x minus c is a factor, then f of c equals 0. So there's a one-to-one correspondence between the zeros of f of x and the factors of f of x. There's a one-to-one correspondence. And again, I showed you back here, right, that if you divide and you get a remainder of 0, that makes you a factor. Okay? And so because if x was negative 2 plus 2 is 0, right? So this whole thing is equal to 0 when you plug in negative 2. This whole thing has to be equal to 0 when you plug in negative 2 because of this factor. Okay, so that's why the factor theorem works the way that it does. How do we apply it? This is the type of problem you'll be given. Solve the equation this equal to 0, this polynomial equal to 0, given that negative 1 is one of the zeros of that function. So 15x cubed plus 14x squared minus 3x minus 2, if you plug negative 1 in there, you get 0. Because negative 1 is a 0 for that. X minus negative 1, in other words, x plus 1, is a factor of f of x, right? If you plug negative 1 in here, you get 0. So what we're going to do is we're going to divide by x plus 1 to find the other factors, but we just used synthetic division, so let's do that. 0, it's negative 1. What are our coefficients? 15x cubed plus 14x squared minus 3x minus 2. Okay. So we're going to do synthetic division, bring the 15 straight down, times negative 1 is negative 15. Add these together, get positive 1, or excuse me, get negative 1. Negative 1 times 1 is positive 1. Multiply, or add those, get negative 2. Negative 2 times negative 2 is positive 2. Add those together, get 0. Now, here's the key. You were already told this is a factor. If you don't get 0 here, you've made a mistake. Okay, so what does that tell you? That tells you that this f of x function here, that x plus 1 divides evenly into it and leaves you with 15x squared minus 1x minus 2. And so if we want to set this equal to 0, right, x plus 1 we already got, so now we need to find this either by factoring or by the quadratic formula, and it turns out that 15x squared minus x minus 2 does factor. Okay. It may take you a little while to get there, but basically we get a 5x and a 3x. We get a minus 2 and a plus 1. Okay, so I don't expect you to factor that quickly. 15 times 2 is 30, and then the differing by 1, 5 times 6 is differing by 1. So if you needed to make this a negative 6 plus 5 minus 2, you could do that and get your factoring. So we've got then x plus 1 times 5x minus 2 times 3x plus 1 equal to 0. And that, of course, just means that x equals negative 1. Here, x equals 2/5 if you add 2 to both sides and divide by 5. And here, if you set this equal to 0 and solve, you get x equals negative 1/3. Right? Remember, if we take 3x plus 1 equals 0, that means 3x equals negative 1, and then divide by 3. Right? Same thing for this one. Set them equal to 0. Okay, so you get 3 answers. It's an x cubed problem. You expect 3 answers. And that's the way you use the factoring theorem. So if they say use the factor theorem, what they're saying is you got to do long division or synthetic division to get your other factors, or to get something that can be factored. If this can't be factored, then use the quadratic formula to find your zeros. That's okay too, right? You've got that option. So that's 3.3. Do a lot of practice and work on those worksheets in the Math Lab, and you should be good to go. Thanks.